Hello and what's up to you all, Mindsetters? It is a lovely Monday. My name is Abram and I'm ready to learn more and learn extra with you guys. Thank you for joining us, and I'll be in touch with you guys just to find out how was your day at school. I hope you enjoyed it. By the way, I'm with Natasha today. Natasha, how are you?
I'm very well, thanks, Abby. How are you today?
I'm doing well, thanks. And what are we doing today?
Okay, well, guys, today we're concluding our section on geometry, Euclidean geometry. Today we're going to be looking at quadrilaterals.
Awesome. And another thing to look at, Mindsetters, you know that we're bringing you the Nokia Mobile Mathematics, which is a cool app, and Natasha is going to take you through it just to show you what you guys can do, because it is a nice, challenging mathematics app just for you guys.
All right, Abby, so you obviously have given everyone the website details.
Yes.
And today I see if we go under grade 10, there we go. Let's go back there. And under geometry, Euclidean geometry, because remember there's analytical and Euclidean, and we're looking at Euclidean geometry. If you click on that, you'll see that at number 3 we've got a special quadrilateral section, which is really great because then the guys can go over there and start practicing geometry, and they can take whatever they learned from today's lesson and put it into practice on the site.
Nice one.
Yeah.
Well, let me tell you, to go there, Mindsetters, you need to register by going on the link that I'll share with you guys on Facebook, and your code, it's 2FB5. FB for Facebook, it's 2FB5. That's your code. Otherwise, we'll be posting also the links to your notes on Facebook, and also the links to the test yourself questions, whereby if you answer them correctly, you stand a chance of winning this awesome Casio calculator. Winners will be announced later on the show. So chat with me on facebook.com/learnextra, or follow us on Twitter @learnextra. I'll also be taking your questions. Natasha, over to you.
All right, guys, so today we're concluding the sections that we've been doing so far with geometry, well, the geometry section. We've done lots and lots of stuff over the last 3 weeks. I hope that you have been paying attention and learning how to answer geometry riders. Today, as I said, we're looking at geometry quadrilaterals, geometric quadrilaterals, and what we're going to specifically do is look at the definitions of the different types of quadrilaterals. We're going to discuss those special quadrilaterals, and then we're also going to work through questions based on those definitions. All right? But just a reminder of your challenge question. So here we are given ABCD, which is a parallelogram with diagonal AC. So diagonal AC just drawn on the diagram there. You are given that AF is equal to HC. So AF is equal to HC. You are asked to show that triangle AFD is equal to is another way to say it, or congruent. Okay? Prove that triangle AFD is congruent to triangle CHB. So once again, guys, a reminder that everything you do in geometry, you cannot forget. It's going to come up in a later section. Then you need to prove in part B that DF is parallel to HB. And then lastly, part C, prove that DFBH is a parallelogram. All right, so plenty of time for you guys to get started on that, and hopefully we'll get lots of people saying they got that correct. But we're going to kick things off with a quick summary. And very importantly, when you do geometry, you need to know your definitions. If you do not know the properties of your quadrilaterals, you will struggle. The only reason you will struggle is because you don't understand those properties and those definitions. And you know, maths is never learning work unless we're talking about your theorems and we're talking about learning your definitions. Otherwise, it's just practice, practice, practice. So the one time that you can actually study the theory behind the geometry, learn the proofs, learn the definitions, learn the properties of your quadrilaterals, and then we're going to put that into action later on. So we need to go over those properties and just remind you guys a little bit about that. So first we're going to kick off with a parallelogram. A reminder that in a parallelogram, both pairs of opposite sides are parallel. So both pairs of opposite sides are parallel. Okay, you also have both pairs of opposite sides are equal, and that is marked on your diagram. Both pairs of opposite angles, so that's for example C and A, and then if we look at angle D and angle B, both pairs of opposite angles are equal, and then both diagonals bisect each other. So diagonal BD in this diagram is bisecting diagonal AC. What that means is it cuts it into equal pieces. All right. Okay, let's move on to the properties of a rectangle. Now, a rectangle is a special parallelogram. So it has all the properties of a parallelogram, but the special thing about it is all four angles, all four interior angles, so these ones here, those are all equal to 90 degrees. Okay? Both pairs of opposite sides are parallel. That's obviously coming from the fact that it is a parallelogram. Both pairs of opposite sides are equal in length. Again, the same reason. The diagonals bisect each other. Okay, so far very, very similar to a palm, which is the abbreviation for parallelogram. But if you look at the next point, the diagonals are equal in length. That's different to a palm. Hey, so the diagonals DB and AC, those lines, are equal to each other. So what that will then imply, because remember, the diagonals also bisect each other. So it means that each of these little pieces on these diagonals, they're all going to be equal to each other. All right. So you'll get little isosceles triangles forming in each of those little sections. Okay. Properties of a rhombus. Now a rhombus, once again, is a parallelogram, but the special thing here, it has all four sides equal in length. Okay? Both pairs of opposite sides are parallel. That follows on from the fact that it's a palm. All sides are equal in length. Okay, important. So it's a parallelogram with all sides equal in length. Okay, that should remind you a little bit of another special quadrilateral. Hopefully you're all thinking about that one, where all sides are equal in length. The other thing about the rhombus, both pairs of opposite angles are equal. All right. The diagonals bisect each other at 90 degrees. Okay, so you get right angle triangles forming there. The diagonals of a rhombus bisect both pairs of opposite angles. So as you can see on your diagram, the diagonals will bisect the opposite angles. Okay. Now we're going to move on to the properties of a square, and this is what I was saying to you. You know, start thinking of another shape where all four sides are equal. A square has all the properties of a rhombus and these additional special properties. Because remember, in a rhombus we said all four sides are equal, but we know from grade 8 that a square also has all four sides equal. What's the big difference between a square and a rhombus? In a square, the interior angles are 90 degrees. Okay, in a rhombus, these are not 90 degrees. Okay, the diagonals are equal in length, so that should straight away get you thinking. Okay, because remember, none of these are done in isolation. All these quadrilaterals, they're related to each other. Okay, some, like in this case, if you look at the square, it's related very specifically to another quadrilateral. These diagonals are equal in length. It should remind you of a rectangle. So what we're saying is that all squares are in fact rectangles. So all squares are rectangles, but not all rectangles are squares. Okay, bear that in mind. Okay, the diagonals bisect both pairs of interior opposite angles, so the same property as a rhombus, except for obviously because these interior angles are 90, each of these will be 45 degrees. All right. Next we move on to a trapezium. So a trapezium is a special quadrilateral with one pair of opposite sides parallel. So as you can see, you also get something called an isosceles trapezium, and that's where a pair of the opposite sides are also equal, which then implies that the base angles will be equal to each other. All right. Then we move on to the properties of a kite. You all know what a kite is, the thing that flies in the sky, yeah? It is a quadrilateral with two pairs of adjacent sides equal. So if you have a look at the diagram, two pairs of adjacent sides are equal. All right. We also know that one pair of opposite angles are equal. That's the angles are between the unequal sides. So one pair of opposite angles are equal, and these angles are between the unequal sides. All right. So we're talking about which pair of opposite angles are equal. The ones between the unequal sides. What are we saying there? These ones. Angle D and B are equal. All right. We also know that the diagonal between the equal sides bisects the other diagonal. So if we look at the diagram, the diagonal, they're saying, between the equal sides, so remember your equal sides here being AD, AB, and DC and BC, that diagonal AC is going to bisect diagonal BD. So that means these portions here, let's mark it with an X, these portions are going to be equal to each other. All right? And the diagonal between the equal sides bisects the interior angles. As you can see on your diagram, those are bisected by that diagonal. And the diagonals intersect at 90 degrees. All right. Now, we're just going to put all of that together and show you the relationship between the different types of quadrilaterals. So remember, quadrilaterals obviously any four-sided enclosed figure. We went over our kite with the properties that we just had now, all those special properties. We went over the trapezium. You can see that those are edging out on the end of the diagram by themselves, meaning that you cannot say that a kite is a parallelogram. You cannot say that a trapezium is a parallelogram. It is not related to the parallelogram. However, when you come down this diagram to the portion where we've got parallelogram, these are in some way related. Okay, so that's why they're all connected to the parallelogram. So what are we saying? We're saying that a rhombus is a parallelogram. We know that a square is a rhombus. All squares are rectangles, and all rectangles would have had to have started out as parallelograms, and then you add those special properties on. All right. So, lots and lots of theory for you to learn. If you like history, if you like learning theory, this will be a piece of cake. Learn this off by heart, and you'll have no problems answering the questions that are coming up a little bit later on. I think it's a good time maybe for us to take a break.
So true, Natasha, and I must go through some comments from the masters watching the show and enjoying it. Noltano says, "Hi, Abram, I'm watching Maths grade 10 with my mom. So she says it's impossible for me to watch Maths and be busy with Facebook. So please call my name on the screen, Noltano Nkavinde. A picture out to you, Noltano. Yes, mommy, she is watching and she's learning, I hope." And the last comment is from Gift saying, Gift Smith says, "This is becoming more and more interesting. That's the true spirit of a mindset." So excited about the show. Thank you so much, Gift. And to all mindsetters, make sure that you chat with me on facebook.com/LearnExtra. The challenge question is already on the wall. So do some beautiful working there and get the details for the Nokia mobile mathematics. See you after the break. Welcome back, awesome grade 10s. Now, I must tell you guys, this is a secret. For you to enjoy our shows, you need to get your notes. That's simple. If you miss any of our notes, whether it's last week's show, remember you can always go to learn.mindset.co.za and look at our beautiful website. But talking about notes, there's something that is hidden on the notes, which are the test yourself questions. If you answer them correctly, you stand a chance of winning this awesome Casio calculator. And our winner from last week's show, Natasha, drum roll, please.
That's not really a drum roll, is it?
Yeah.
It's more like a king calling. We're going to have to start getting sound effects.
All right, I'm sure Abram is working on that.
Yes.
Right, our winner from last week's show, grade 10s, it's Pilani Pungwayo. Congratulations to you, Pilani Pungwayo. This awesome calculator is coming your way because I know that mindsetters some are writing their exams, so it's good that they need a calculator.
Absolutely.
It must always be in their bag, especially if you're going to write mathematics. I think it's
You can't do it
impossible.
without the calculator. Absolutely not.
Unless you're a genius.
Even then, some functions you still can't do in your head.
Right, and you must use it when you're told to use it, hey? Because
Yes,
some
and
instructions
not
will
when-
tell you, do not choose a
Exactly.
calculator.
Exactly.
Right, let's continue and improve our skills.
Okay, all right, guys. So we're back talking about quadrilaterals. We're using the properties that we've gone over in the summary. We're going to use those properties to answer question 1. This is in Improve Your Skills, and we are given parallelogram ABCD. You'll often notice I'll say palm instead of parallelogram. It's the same thing. parallelogram ABCD with AE and FC. So those are just line segments that are drawn. Now guys, what I'd like to do is, before even reading the question, I always find it helpful if they give you a specific type of quadrilateral. I find it helpful to put down what you know about that specific quadrilateral. Put it down on your diagram because it might assist you later on. Okay, so I know that this is a parallelogram. Things I can put down. I know that AB is parallel to CD. I know that BC would have to be parallel to AD because properties of a palm, right? I know that AB is going to be equal to DC. I also know that BC is going to be equal to AD. I know from the properties of a palm that the opposite angles B and D, and then the opposite angles A and C, are also equal to each other. So I've just marked down everything that we sort of know just from the definition, just by reading that without even looking at the question. Sometimes things unravel and you can see the answer immediately just from plotting down or writing down what you know. We go on and it says AE bisects angle A. So obviously if it's bisected, it means cuts in equal pieces. And you can see that they've marked that angle DAE is Y. So if AE, right, bisects angle A, that means that angle EAF must also be Y, right? So these are things you mark down just from reading the given information, right? They also tell you that FC bisects angle C. Now things we can mark down here. Remember we said from properties of a palm, we know that opposite angles are equal. So therefore if angle A is equal to 2y, angle C is also equal to 2y. But the fact that FC bisects angle C means it cuts it into two little pieces. So therefore angle FCE and angle FCB are both equal to y. Alright, so you see what we've done there. We've just read the given information. We haven't even started answering any of the questions. We just read the information and we use that to mark down everything we can on the diagram. Okay, now let's look at part A. They say write down all interior angles in terms of y. Okay, well we've already started. Hey, look, we've already marked down what angle C is going to be. So let's go, this is part A. Alright. And we're going to give reasons for these as we go on as well. So we can say angle EAF, this one, is equal to y. And the reason for that is AE bisects angle A. And you were given that information, right? Okay. Another thing that we can mark down immediately, so I'm just going in order of what is apparent. Another thing we can mark down is angle C is equal to angle A. That's obviously because it's opposite angles of a palm. Therefore, we have that angle FCE is equal to angle FCB. Alright, those two are equal. And they're both equal to y, and this is sort of a composite reason. The reason for that is FC bisects angle C. Alright, so we've got that those are both y. Alright, what else do we have? Okay, now remember you've got parallel lines. As soon as you've got parallel lines, you've got to think of the fun diagram that you learned in grade 8. Maths is fun, right? You guys remember that diagram? Okay, you get your corresponding co-interior and alternate angles forming. So, the next one I can list from my diagram using the parallel lines. I can say that angle AED, and guys, please get used to naming sides from the points in your triangle or on your line segments or whatever the case is. You need to understand that if I'm saying angle AED, I'm talking about the middle one there. Alright, so that little angle E there, that's going to be equal to y. And the reason it's equal to y is because of alternate angle. So it's equal to angle EAF because of alternate angles. Alright, And then we can get another one here. We can get, let's carry on with our alternate angles. We can get that angle CFB, that one, is also y for the same reason. So angle CFB, CFB is equal to y, and that's alternate angles with angle FCE. So it's alternate to angle FCE. Right, so we've got that angle there. We know what this one is. What else is missing? Now they said label all of the interior angles, or all the angles that you can find in this diagram, right? We also know now, looking at this little triangle ADE, okay, we know that angle D is going to be 180 minus 2y because of angles in a triangle. Right, so we can mark that down. So this is another one we've got. Angle D is equal to 180 minus 2y because of angles in a triangle. Right, we know that because ABCD is a palm, angle D is going to be equal to angle B, or we can also get angle B the same way we did angle D using angles in a triangle. So this is angle B is also equal to 180 minus 2y, and that you can say is opposite angles of parallelogram. Alright, so we know that B is 180 minus 2y. Okay, and they say write down all the interior angles. So we've got, so far we've got everything. The only ones that are left, the last couple of interior angles, are this one here and this angle AEC. So angle AEC is going to be 180 minus y because of angles on a straight line. Similarly, angle AFC is 180 minus y because of angles on a straight line. All right, but we've got all of our interior angles, A, B, C, D. Right. Now the next part. So usually with these types of questions, your part A is generally going to be useful in answering part B. Part B says prove that AFCE is a parallelogram. So they're talking about this one. And you see we've got so much of information here already that we can use to help us, right? So we're proving that AFCE is a parallelogram. Now guys, how do you prove that something is a parallelogram? All right, you have to, hopefully you all know this and you're all shouting the answer there, you have to use the properties of a parallelogram to show that something is a parallelogram. What properties do you have? You've got that whole stack of them that I showed you in the beginning. For example, we could prove one pair of opposite sides is parallel and equal, therefore the shape will become a parallelogram. Or we can prove both pairs of opposite sides are parallel, or we could prove both pairs of opposite sides are equal, or we could prove opposite angles are equal, or if we had diagonals, we could prove the diagonals bisect each other. So there's so many to choose from. You've just got to decide what works best for the diagram you are given. So you've got AFCE, right? What's going to work best there, right? Well, I think just from what we are given, probably the one that's going to work the best is opposite angles being equal, because we've already shown from previous working that angle EAF is equal to angle FCE. All right? We already know that angle AFC is equal to angle AEC, right? Therefore, both pairs of opposite angles are equal, so therefore AFCE must be a parallelogram. Let's write that proof down now. Okay, so this is part B, and here we are proving, in this proof, we need to show that AFCE is a parallelogram. Okay, so we can say, firstly, angle EAF is equal to angle FCE. So angle EAF is equal to angle FCE. Now guys, if you have already shown this before, you can just say proved above. You don't have to restart writing the entire proof out, right? So proved above. Okay. We also know that angle AEC is equal to, so angle AEC, that's this one here, that is equal to angle AFC, and they're both equal to 180 minus y, and here it was angles on a straight line because I didn't actually write the proof down above, so therefore it was angles on straight line. We showed that they were both equal. Both were equal. We showed that they're both equal 180 minus y using angles on a straight line. So therefore we've got AEC is equal to AFC, EAF is equal to FCE. So you say therefore AFCE is in fact a parallelogram. And the reason for that is both pairs of opposite angles are equal. Alright. So both pairs of opposite angles are equal, therefore we can say it's a parallelogram. If you wanted to prove maybe both pairs of opposite sides are parallel or a different way, there was another way that you could show this, yeah, for sure. So if there is another way that you use to show it, as long as you're using the right definitions and properties, then you can also show it's a palm in a different way. All right, but still using the correct properties. Don't mix up those properties. Okay, hopefully you're all following me with this and ready to now carry on with question 2.
Still on that question 1, Natasha, Lisonon is asking, where did you get the y?
This y?
Yes.
That was given. The initial y was given. It was drawn on the diagram. So if they didn't give us that little angle A there, angle A, DAE, if they didn't tell us that's y, then we could have named it ourselves. But in this case, it was actually given that that angle was y.
All right. Thank you.
Okay, so let's move on to question 2. So here we are given that triangle PQR and triangle PSR are equilateral triangles. Again, drawing on definitions that you've learned before. What is an equilateral triangle? In an equilateral triangle, all the sides are equal to each other and all of the interior angles are equal to each other, and in fact you go one step further and all interior angles are equal to 60 degrees, right? They say prove that, so given those two sets of equilateral triangles, prove that that quadrilateral PQRS is a rhombus. Now what is a rhombus? We went over this definition earlier. You need to again just have it in your head there, learn it, understand the definition of a rhombus. A rhombus is a special parallelogram, special because all four sides are equal to each other. Okay. So if I want to show that this is a rhombus, I firstly need to show and convince people that it's a palm, and then once it's a palm, palm being parallelogram, then if all four sides are equal to each other, then in fact it's a rhombus. Okay, so let's have a look at this one. So we know that triangle PQR is equilateral. That means that PR is equal to QR is equal to PQ, because that's what happens in an equilateral triangle. We can even go further and say P2 is equal to 60 degrees, PQR is equal to 60 degrees, and R2 is equal to 60 degrees. Alright? We also know PSR is an equilateral triangle. Obviously PR is a common side between the two triangles, so therefore these sides are actually all going to be equal to each other, right? Because PR is that common side between both triangles, right? So PR is equal to PS is equal to SR, again because they told you it's an equilateral triangle, and you can also put in your 60 degrees. All right. So how do we show that it's a palm? Well, we can say in quadrilateral PQRS, so this is my proof now. All right, I know firstly that PS, side PS, is equal to side PR, right? And the reason for that is that it was an equilateral triangle. Equilateral triangle, okay? I also know that side PR is equal to side QR. And so that was, okay, so the first one was equilateral triangle. Let's name it PSR. Second one is going to be equilateral triangle. And this time it's PQR. Okay, so we know from that triangle that PR is equal to QR. But obviously PR is the common thread there. So therefore, if PS is equal to PR and QR is equal to PR, it follows logically, which is what geometry is all about, logic, PS must be equal to QR. They're both equal to PR. Right. So we've shown that PS is equal to QR. And then we can say something that we use a lot when things are almost identical. Similarly, okay, we can show that PQ is equal to SR. So similarly, PQ is equal to SR because they're both equal, side PR. All right. In fact, we can just put that down for those of you who are having trouble following here. So they're both equal to side PR, so they must be equal to each other, right? So I've got, look at this now, we've got PS equal to QR, and we've got PQ equaling SR. So if both pairs of opposite sides are equal, so both pairs of opposite sides are equal, that implies, okay, my writing is getting very untidy, therefore that means that quad PQRS is a parallelogram. Therefore PQRS is a parallelogram because both pairs of opposite sides are equal. But we can go one step further. Now there's two things you can do. You can either show that this diagonal PR, bisects the angles, right? So therefore it's a rhombus. Or we can go on to say, well, PQ is equal to QR is equal to SR is equal to PS. And that's what we're going to do because all the sides then are equal to each other. So PS is equal to SR is equal to QR is equal to PQ. Alright, and that's because they were all equilateral triangles, and we've shown that PR is this common thread between all of them. They're all the same length. So since all the sides are equal, so therefore we know that PQRS is in fact a rhombus. And the reason for that is it is a palm with all four sides equal to each other. Okay. So because it's a palm with all four sides equal to each other, that means it must be a rhombus. But as I said, you can also use the fact that the diagonal bisects those angles, those opposite angles, interior opposite angles, and you could use that as your proof for a rhombus. All right, guys, so when we come back, we've just got one more thing to do, AB, and that's to tackle the challenge question.
Exactly, but more than that, it is your questions, Mindsetters. If you're struggling, send me your questions right now because Natasha is up and ready to answer them. We'll see you after the break. Welcome back, my sisters. Now, if you just joined us now, you're a bit late, but you can still catch up. The challenge question is on the page, and Natasha will be answering very, very soon. So if you have some questions, make sure that you throw them at me on facebook.com/LearnExtra or on Twitter @LearnExtra. But now, before I give it back to you, Natasha, I've got a simple exercise, hey?
A simple exercise. Okay,
Yes.
let's hope we've
It's
got
not,
time for
it's
this.
not a challenge question. It's one of the posts that we've posted on the page today. It says, think before you speak. You know, think has got 5 characters. It's T, H, I, N, and K. So T means when you think before you speak, you're asking yourself a question that says, is it true? So before you speak something, you ask yourself, is it true? And then H, is it helpful? And then I, is it inspiring? And then N, is it necessary? Because some of the things, you know, they're unnecessary. And then the last one, the K, means, is it kind? So you must value that before you speak. Think of those things. And then if you feel like it's not worth it, then rather not say it. So let's all think before we speak.
And especially, guys, especially for those of you writing exams, think before you ink, even more importantly. All right.
Nice one.
Okay, guys, so challenge question. We've got that ABCD is a parallelogram with diagonal AC is given. You're also given that AF is equal to HC. So what I said to you, everything you marked down on the diagram, most of it is already marked down in this diagram. We know that AB is parallel to DC, BC is parallel to AD. We know that side AB is equal to side DC. We know that side BC is equal to AD, and I must just be careful not to use those same symbols later on. And then they gave you information. They told you that AF is equal to HC. Okay, so that's given, right? Okay, we obviously then have all of the alternate angles going to be forming here. We have opposite angles of a palm, and all of that is going to perhaps come in some sort of use later on, right? So the first question says, show that triangle AFD is congruent or equal to triangle CHB. So AFD, right, so show that that one is congruent to this one. Remember, when you're proving congruency, the order in which you name your sides is important. All right, so make sure that the order in which you're labeling these is correct. So this is part A, and we start our congruency by saying in triangle, and we name it according to what they said there. We've got AFD and triangle CHB. Now, before you prove congruency, remember you've got to state 3 things. And those 3 things come from and depend on what you are given in the diagram and what you can use to prove your congruency. Remember, in congruency, you can prove side angled side. You can prove side, 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 prove that all the sides are equal to each other. You can prove angle, angle, side, or you can prove right angle, hypotenuse, side. So you've got to use any one of those 4 reasonings in order to prove your congruency in this case. All right, so let's look and assess what we've been given. Well, we know off the bat that AF is equal to HC. It would be silly not to use that. That was just given. It's an easy, quick mark that. So we say, well, one reason, AF is equal to HC, and that was given. So what do we have there? We have a side. Okay? We then look at the diagram again and see, well, what can we say about angles and what can we say about other sides? And guys, what you'll notice, right? Remember now, we said that AB is parallel to DC because it's a parallelogram. So if I follow this shape, have a look at this. So we go from A to B and then all the way down. We do that. All right? Okay, so we've got that. And then similarly, I can do this. I can go from, and I'm going to use a different color here. I'm going to go all the way along AD. Okay, and let's see if we can use that one. That one, there we go. Going all along diagonal AC and across. Okay, now the reason I'm putting these pinks and blues in is because I want you guys to start realizing and start seeing the parallel line angles, the angles that you get formed, those alternate angles, co-interior, corresponding. Look out for those, okay, from the diagram that you've been given. All right. Now we know that if I'm following along AC and I'm using the fact that AB is parallel to CD, I would get that angle C2 is equal to angle A2. However, that does not fall into the triangles that I'm interested in. So to make a statement like A2 is equal to C2 is unnecessary. So there we go. AB was saying, think, the N stands for necessary. Is it necessary to say that A2 is equal to C2? No, because it does not add any value to your proof. However, if you look at angle A2, which falls within the triangle that we're interested in, and if you look at angle C1, sorry, also falls within the triangle that we're interested in, those are equal to each other because of alternate angles, because AD is parallel to BC. So there we go. We've got an angle. So I can say angle A1 is equal to angle C1, and the reason for that is alternate angles. Which lines were parallel? Well, it was AD is parallel to BC. All right. So we've got an angle. So I've got an angle now, and I've got one side. Let's look for something else. All right. What else can we get? So far, I've got that AF is equal to HC. I've got that C1 is equal to A1. I need one more thing, and the one most glaring obvious thing from the properties of a palm is that AD is equal to BC because it's opposite sides of a palm. So therefore I can say AD is equal to BC, and the reason for that is opposite sides. Equal opposite sides of palm A, B, C, D. Alright, so they're equal to each other because we know that both pairs of opposite sides in a palm are equal. So let's analyze our reasoning. We've got a side, we've got an angle, and we've got a side. So therefore, we can say triangle AFD is congruent to triangle CHB, and the reason for that is side, angle, side. Okay. Now, very importantly, whenever you prove congruency, remember you're going to get deductions from that congruency. So from us proving these two triangles are congruent, we get some follow-on logical deductions, right? So for example, if I know that this triangle AFD is congruent to triangle CHB, following from that congruency, I will be able to state that angle F1 is equal to angle H1. Okay, that's just a deduction. They're not asking me to do anything or to show it. I'm just showing you guys because you may need it later on, right? Also, following on from that congruency, you will get that side FD is equal to side HB. So deduction from the congruency. And then the last two angles that are left will have to be equal to each other. So this one here, make it a big circle rather than a little circle, will be equal to that. Alright, so those two will be equal to each other. Okay, part B says prove that DF is parallel. So DF being this side here, prove that that is parallel to HB. Prove that those are parallel. Well, how do we prove that lines are parallel? We only know really one way to do it. We've got to look for those angles, the alternate, the corresponding, and the co-interior angles. We've got to look for those special angles and see if they exist in our diagram. If they do, then we can say that those lines are parallel. That's how we're going to do this one. So remember, we've just said from the congruency we know, so you see that deduction is going to come to help us now, turn out to help us. We know that F1 is equal to H1. Okay, the reason for that, so this is part B and I'm doing it along the side here. We know that angle F1 is equal to H1, and that's because those triangles AFD and triangle CHB were congruent to each other. Okay? So from there we've got F1 is equal to H1. But I know that angle F2, right, is going to be equal to 180 minus F1 because of angles on a straight line, right? Okay, so F2 is 180 minus F1. Similarly, H2 is going to be 180 minus H1. But we know that these two guys here, F1 and H1, are equal to each other. So really what we're saying is F2 must be equal to H2 because they both equal the same thing. Because I can say, therefore, F2 is actually equal to 180 minus, instead of F1, I can replace that with H1 because we know that F1 was equal to H1, right? So if they're both equal to 180 minus the same angle, they must be equal to each other in magnitude, okay? Some of you might find it easier to work with, for example, letters. So I could say let angle F1 be Y, then angle F2 would be 180 minus Y because of angles in a straight line. Similarly, H1 would be Y because it's equal to F1, and then H2 would be 180 minus Y because of angles in a straight line. In that way, you can show that H2 is equal to F2. So if you prefer working with variables, feel free to use them. If you don't need the variables, that's great. So we can say, therefore, angle F2 is equal to angle H2 because of that reasoning above. But these are alternate angles, right? Alright, so these are alternate angles. So therefore, that implies that FD must be parallel to HB. Okay, so therefore, if we've got F2 being alternate to H2, those two lines must be parallel to each other in order to form those alternate angles. Okay, so therefore we've proved that FD is parallel to HB. Okay, and that takes us to the very last part, guys, which is now saying prove that DFBH, which is the little quad in the middle, prove that that is a parallelogram. Now remember, you're going to use what you've just proved, and what you've just proved is that FD is parallel to HB. So it makes sense to use what you've just proved rather than now go and try and prove, for example, that FB is perpendicular to HD, because that's going to take a lot more work. While it can be done, it's just going to take more work, right? So let's use what we already have. We know that FD is parallel to HB. We know that one way to prove that a quadrilateral is a par is to prove that a pair of opposite sides is both parallel and equal. So we have that the opposite sides are parallel. We just need to prove that FD is equal to HB, but we don't really have to prove it at all, hey? Because from the congruency, we deduced that those two were equal. And you see, geometry is so nice and so fun. When you do things correctly, it all just falls into place. So we simply have to make statements here in part C. All right. So part C, we're going to say that FD is equal to HB. And the reason for that was because those triangles were congruent. So this was proved from congruency. Okay, or you can again state which triangles were congruent to each other. So FD is equal to HB. We also showed in part B, okay, so this was proved that HB was in fact parallel to FD. Therefore, the quadrilateral there in the middle, that quadrilateral DFBH, so DFBH is a parallelogram, and the reason for that is since one pair of opposite sides is parallel and equal. Okay, so because we showed that one pair of opposite sides is parallel and equal, we can then claim that that quadrilateral DFBH is in fact a parallelogram, and I think that's pretty good timing, hey, because we are almost out of time.
Right on time, hey. But otherwise, there's some great comments about the show on the page, so really appreciate. It means we have done our job. Just one
Yes.
comment. It says, before the show I was in the dark, but now I see the light watching the show, and I didn't understand geometry, but I can see now that it's just a piece of cake. That is from Zoe. So thank you guys for all your comments, and really appreciate Natasha.
Pleasure, pleasure, pleasure. Study, work hard, and we'll see you guys next week, Monday.
And
Well,
remember,
I'll see you guys next Monday.
and remember, always think before you ink on that paper. Otherwise, we love you guys, and peace. We out.